Hello everyone, myself Sumit Gaur. Welcome to all of you in this video. In this video, I will demonstrate Vernier function, Barry curvature, and band unfolding calculation using the Rescue software through the MATLAB coding. So first, we need to take our material from the device studio. So we have to first create a new project. I will create a new project with Nano, and you can see this is your device studio. I will take some material from the online library and offline library as well. You can see I will take first carbon, copper. This is copper. This is a copper molecule. Then next I will take the another one. Now I will take this material, and the third one I will take Cu3 Au. You can see I take three materials of them. You can see I will calculate the band unfolding, Vernier, and Barry curvature for all of three of them. So you can do it into the center. So now first we have to create the folders for using the calculation. I will use the rescue software. You can see simple SCF for whole of them. You use LCAO, that is linear combination of atomic orbital. Generate files. For this I have to also create the input file for this CU as it is, and for copper Cu3AU do same. Now the next thing, I'll take the whole of a material. Then after I will browse this file directory into the MATLAB. So the next thing I have to open the MATLAB. You can see this is MATLAB. So first we need to browse the file directory. Now you can see all folders are coming into the MATLAB. So first we'll go with the Vernier function. So for Vernier function, we'll take the CU in which we will create input files for Vernier input, SCF input, and Vernier input as well. So let it be open, this input file. I will not take the default input. I will not take this one. I have to change the whole input file. Now you can see this is my input file for this SCF input of that CU. I had taken this input file. Do save. So to run the calculation, you have to only write rescue I scf dot input. You can see your calculation is getting started, and after that now our now SCF input is finished. Now next thing is we have to create a new input for the Vernier band. So you can copy this file and paste it here and use this. Now you can name with name CULCO van dot input. So this is the input file I had created for this Vernier input. So you can see in the input file, I'll have to change the input as well. So I will not take this input, I will remove it. This is the input file for the Vernier calculation. So I will run it. You can save this and do run. Yes, save. And you have to write this input file with rescue I. Click run. Now you can see your Vernier input is getting started. This is a Vernier function calculation. So in the meantime, we can calculate Vernier band structure. So we will import, will try to create input file for Vernier band structure. Now you can see your Vernier input calculation is Vernier function calculation is completed here. As you can see here, your Vernier calculation is completed. After that is projection transformation started, in which it optimize the projection transformation, and after that it's minimize the spread functional, and now the Hamilton is Gauss and Vernier calculation is here calculated. Now you can see I in the meantime I created the input file of the Vernier band structure input. So I wanted to show you your calculation completed here. So this is the input file for Vernier band structure. So you can see you have to write it on and save it, in which I had described the calculation name type, and it is the output file where it will be saved after the calculation, and this is the save path of that result. You get it from the Vernier input, and this is the result where it will be saved after the calculation. You have to save it, this input file, and run this and do as. Now you have to run this input file again, not again, and you have to run this input file when your band structure. So you have to write rescue I LCAO. LCAO stand for linear combination of atomic orbital, which we are tool using here. Now you can see your Vernier band structure calculation will be started. Beginning Vernier band structure calculation. Here you can see the time of the calculation when it will be started, and it is running. So when the calculation will be getting completed, after that to see the result, you have to type some one more script into the Vernier band structure input. So let it be getting completed. You can see your Vernier band structure calculation is completed here. Now we have wanted to see the result into the uh, graph form. So you have to open the input file of Vernier band structure input WBS, and you have to write input script form rescue. P stand for plot, and you have to give the path of this save path, copy and paste, and do save. After the saving, run this calculation again. You can see and run it. Now you can see this is the Vernier band structure calculation which you had completed. Now the next part will be to have to calculate the Barry curvature of this B, C2 and 1. Okay, so first we need to open the SCF input of this file. So I will not take this correct input. I have to change some input value into this SCF input. So the next thing we have to calculate the SCF input for the Barry curvature. So first we need to put the value into the SCF input. So I will be open this input file and I will change the input values. So it will be same as it is here. No need to be changed. So let it be same here. And you have to type rescue iscf dot input. Now your calculation is started here. So now your SCF calculation is completed here. So you have to create a new input file for the barrier curvature. So now you can see here I created the barrier curvature input in which I given these values. Uh, the calculation name is barrier curvature and the path where it will be saved. And this is the input file for that calculation. And I will be save it. Have to remove this and Control S save and run it. Now you can see your barrier curvature input is getting started. See our barrier curvature calculation is completed here. To see the result into the graph, so you have to change some input value. You have to write some script into this input of barrier curvature. So you have to give this path and Control S, or you can save it and run this. So here we are doing the mistake. So you have to do P, save it, and do calculation again. And now you can see this is the Barry curvature for your material which you are taking BC2N, B1 C2 N1. So now you can that matter you can calculate the Barry curvature of the any material or any material using the rescue software into the MATLAB. So now the third part one is we have to calculate the band unfolding. So let me stop it. Now we have to coming on the third part, which we have to calculate the unfolding band unfolding. So first we need to calculate the SCF dot input file. So I had already take the input of this SCF for that material which we had taken. This will be the input file. Let do the save and now we have to run this calculation using this. Now in the meantime, I will be try to create input file for the band unfolding. So you can see your calculation is started here, your SCF calculation. Now you can see your SCF calculation is completed here. So now we have to create the input file for band unfolding. Now you can see this is the input file for band unfolding which I had created. You can see this is the calculation type. This is the path save where we will be save the path of that band structure, and this is the output file, and this is the SCF file of that material which we had calculated. Now that we'll do the save and run this input file. To only type here I. You have to type for doing the calculation. You have to take the I. For plotting the calculation, you have to put P. So now your calculation for unfold band unfold is getting started. So band structure is calculated. After that, it started the unfolding calculation. So you can see your calculation for band unfolding is completed here. To see the result into the graph form, you have to put some script value like which we are doing rescue -p. These are the very simple codes you have to written, and you have to give this path and do save and run this again. Now you can see this is the your band unfolding calculation using the MATLAB for the rescue software. So maybe you everyone get the point what we are doing, how we use this rescue software into the MATLAB, and how can you calculate the band structure and unfolding and linear functions, linear calculations, linear band structure, and many more property you can calculate like this. So thank you everyone to watching this video.